Hey guys, it's my pleasure to introduce Xavier Garcia. Xavier is an old friend of mine who's an AI researcher. He was one of the authors of the Palm paper, which is Google's large language model. Before this, he received his PhD from Northwestern. Okay, so let's just jump right into it. Yeah, so thanks for joining. So what should we talk about today?
Let's see. There's been plenty of exciting things going on recently, like GPT-4 came out a few weeks ago. That has really shaken up many people's perceptions. The popularization of like kind of open source or public large language models like llama are also pretty exciting. Any of those seem pretty good to me. But if you have
Yeah,
any topics you want to talk about,
I was gonna say, yeah, it's actually been a few weeks. It's been a few weeks since we've talked, and yeah, so actually, this has been a pretty busy few weeks, right?
yeah, for sure.
Uh,
Crazy.
I know, crazy. Yeah, it's like progress is going so rapidly. I'm kind of interested in like these the replications of these bigger models with like a small number of weights, because I think one of the big, obviously one of the big things that makes these large language models tough to use is they're so big and they cost a lot to make inference. Definitely a lot to train. So yeah, let's talk a bit about that. So first of all, what's happened in the past couple of weeks, in case for those who don't know.
Yeah, so I think probably the most exciting thing in that front is that people have been taking. Okay, so for more context, Facebook had released this family of like language models called Llama, and they kind of range from across several orders of magnitude in sizes, and they were trained for a very long time, and they actually released the weights. Um, well, you could ask for the weights from, and then if granted, they will give you access to the weights. And then since then, the weights have been leaked, and people have been using these models to do a variety of things. But in particular, they've been attempting to reproduce like ChatGPT or build ChatGPT like interfaces. And it's been now multiple such groups. I think the first one was this alpaca model, where they just took examples of ChatGPT and then they fine-tuned one of these models using that data. But there have been a host of other models, all with similar sounding names that kind of do the same thing. So now I think it's getting a bit hard to know which one is the best because they don't really compare against each other, or we have no real benchmark for these models. But it seems to be getting easier and easier to actually like create some of these models, or like create like chat versions of these models, if you would.
Cool. So then okay, so if we compare the sizes of like say GPT-3, I guess would be the comparison versus like some of these smaller models, what are like the number of parameters or that kind of thing?
Yeah, so we should be a bit careful. So I mean, we don't know what's powering ChatGPT, for example. We don't know. Like we do know that they also updated their models. So instead of like they have a GPT 3.5, but we don't know anything about their architecture, I believe. So I mean, we should be a bit careful, I think, with making these comparisons. But we can of course compare with the GPT-3. So that was like about 175 billion. And I believe now some of the more popular like llama models are like at the scale of like 7B. So like it's almost 2 orders of magnitude smaller. And it's not just the size, but people have actually started developing like optimized software for this, so that you can actually run inference on the CPU and not just have to rely on like a very powerful graphics card.
That's right. I think I even saw, did you see the thing about the Raspberry Pi and running inference on that?
Oh no, I haven't seen that, but that sounds incredible too.
Yeah, large language model of Raspberry Pi. I think it takes like 10-15 seconds to make an inference, but pretty cool.
Yeah, for sure. I mean, I think as time goes on, these models will be more and more like easily used, even in local settings.
So then, do you know what the key or what maybe some of the key ideas were in being able to shrink these models?
I mean, I don't think that. So, like, from like a maybe like academic standpoint, I don't think there were any real new ideas. So, I think a lot of the ideas for these things have already been known for a long time. It's just a matter of like getting the compute and getting the maybe engineering expertise to train these models. So many things can go wrong when you go to train these models in terms of like training instabilities or bad data quality, and even properly designing training training infrastructure for this can be quite difficult. So that's why we're seeing like only the more powerful labs are able to actually train these models, like the larger models.
But like to go from 175 to 7 billion, do you know any of the techniques that were kind of used there?
Well, right. So I mean, like, so we should be a bit careful with that kind of comparison, right? So like, I'm sure if you just take the base model as is compared to GPT-3, like, I'm sure there are benchmarks where the largest GPT-3 will do better. But of course, like, we are closing the gap, or like the community, let's say, is coming close to that gap with smaller models. And I think, it really comes down to just training for much longer. So GPT-3 only trained for 300 billion tokens. Meanwhile, the llama models were trained for far longer. I don't recall how many tokens, but they were just trained much longer, even much longer than the chinchilla optimal recipe will tell you to train. So, and I think they also had better data quality filters than GPT-3. I mean, GPT-3 is a pretty old, if you would, paper by now. So people have developed better techniques for data filtering.
Makes sense. Do you think so fair enough that the 7 billion models maybe aren't as good as like the 175. They're just kind of closing the gap. Understood there. So what do you think, what would you guess would be like a kind of limit? I guess it's hard to define exactly what I mean by limit, but how small can these models get before they're, hopeless at achieving even close to some of these larger models?
Question as posed is not actually very well posed. So, I mean, we don't even know right now with the current models that we have, how good are they in some sense. So like we have Alpaca, we have all these other versions, but we don't have any real benchmarks that allow us to compare for the things that we want. Like maybe we don't need a giant model for having a simple chat assistant. Maybe we do. Or maybe if we equip the models with more tools, like ability to use search or use like, calculators or whatever, right? Maybe we can get away with small model, or perhaps for more specialized use cases, having a small model is enough. I think we first have to figure out where are we, like how far away are we in the task that we actually care about, and then we can start sort of assessing whether we need more or less, and like also just how much we're willing to pay, right? Like like what's wrong with having a giant model, for example, doing things, right? So like if you can just run it on CPU, then fine, it's slow, but maybe you're okay with it being slow. Like it's not clear what the latency requirements are, for example. So it's a bit hard to answer the question, I guess is what I'm trying to say.
Well, I mean, you mentioned at the end, what's the problem with these larger models? Well, I guess one of the problems is that these things are hard to build, right? So the people who actually have these models ready to use are, quite a bit less than if the models were a lot smaller and easier to use.
But so you mean to build them or to use them?
To build them.
I mean, so I guess what makes you think that training a small model that's as good as a giant model will be easy?
Yeah, okay, that's fair. So you're saying because we're training longer, maybe it doesn't actually decrease like the amount of compute that's needed too much.
Yeah, maybe, or maybe even at some point, like the amount of data that you need to train these small models to get to that level, maybe it's beyond what we currently have. Or yeah, so I guess it's not super clear at what point like it's actually cheaper to build these small models, or easier in some sense, like easier from like a purely, let's say, train flops perspective.
Right. Yeah, that's fair. I guess, yeah, what we need, well, yeah, it would be nice to have an, open source version of, some of these smaller models that people could get their hands on.
Yeah. I mean, I think even open source is tricky. Oh,
That's right. There's kind of exist in some sense, but a lot of these models are quote unquote open, but then it's for research only, I guess.
Right. Yeah. They have maybe not so permissive licensing. I think just recently there was a family of like LLMs that came out. I think up to 13 billion, if I'm recalling correctly, and those are actually fully open source.
Where is this?
I think these are the Cerebra models. I think just released like 2 days ago or something.
Oh wow. Okay.
Yeah, I mean, of course, it didn't go as big as the like the 64B llama or any of the bigger ones, but I think like they are, very permissive licensing. So
That's pretty cool to see. Okay, I just have a question pop in my head. I figure we'll kind of slightly change gears. So I was thinking about so a lot of the large language models are kind of just like taking in data from like all different areas and kind of become, I don't know, would you think it's fair to say like a jack of all trades, but not like really a master at too many, or is that kind of unfair?
I mean, so they're definitely becoming a master or a jack of all trades. As for whether that means that they're not a master of any of these, it's harder to say. Or I mean, maybe more than that, it's hard to say like how would you build a master for these things.
Well, that was my next question. So yeah, suppose you are given the task to say replicate a doctor.
Yeah.
What would be your kind of thought process given what we kind of know today? How would you think of going forward?
Yeah, I mean, I think that kind of question requires definitely a lot of unpacking. Even just like what aspect of a doctor do you want to fully like replace, or like what kind of doctor, and like what would you be satisfied with? For example, would you have to like replicate their entire like a physical doctor talking, or would you be okay with the screen, right? Like I think we need to first unpack like what that means. So perhaps
I definitely don't want. I don't want to consider a physical doctor because that introduced too many complications that are. But just like someone who, I mean, someone that you can just ask questions, like say WebMD.
Yeah.
Something like that, but that's large language model based.
Right. So I think I believe like Google has been working on some of these kind of stuff with like MedPalm. And yes, just in general, the real limiting factor right now is more like how do you get enough like medical data or like data about medicine into these models so that they actually like learn about this concept. I think we've already seen that. I think GPT4 reported numbers on like the MCAT and those kind of exams. Of course, like it's hard to know how much like we should value performance on those benchmarks. Like if
Agreed,
you beat out most doctors, like is that good? I mean, does that mean that it's very stupid to be a doctor? Probably not. And so I think like at some point we will have to like think of like what is a proper way to evaluate these models for these kind of tasks. I think for the purposes of using them as a tool, I think maybe it might be more forgiving. Like maybe instead of like replacing doctors, we can augment doctors by giving them access to like a specialized like doctor chat interface that might be able to help like give suggestions or help them like access knowledge faster than just like going online themselves, right? So I think from that perspective, we might be able to make more efficient doctors and therefore perhaps make care more accessible to more people. But I think somehow crossing the line to just fully replacing doctors, I think has some like it's still not clear how to even know that we've gotten to that point. Like even if we have something that is as good as a doctor, actually assessing that could be hard.
Yeah, two things I can think of that it would be immediately cool is one is like an interface where people could, ask questions and kind of get quick answers. I guess the internet is kind of already doing that, right, a little bit. But yeah, in terms of an application of LLMs, that'd be cool. And then the second would be a bit harder, I think, is something that could actually be like a GitHub Copilot or like an assistant to an actual doctor where they have, a tool that they can kind of conduct research hopefully quicker and maybe get a different perspective.
Yeah, I think both are definitely excellent goals.
But then, so I think what I heard from you is kind of the main thing you would consider is just getting medical data and kind of hoping to apply similar techniques.
Yeah, so I think that's definitely the first step. Like, we like if the content is just not in the model, then like there's no way the model will be able to answer questions about that. But beyond that, I think we need to think more carefully about evaluation and how to actually like what does it look like? Like how can we know that we've actually made progress? Or like what are the benchmarks that we need to look at for this?
So maybe zooming back from doctors. So what kind of benchmarks are people usually using to analyze large language models currently?
Right. So I think the most popular thing right now is human evaluation. So you actually just expose like humans to these models, and then they get to they get to either rate how much they like the model's response, or optionally they might compare two model responses, and then they might have to say which one they like more, and maybe potentially say why. And so I think then the question becomes like, what questions should the models be asked, right? So like, for example, I think OpenAI, when they created their Instruct GPT paper, they actually used examples from like user examples from their own API to figure out what kind of test set they should build. And so this sort of gets at this question of like, if you do want to build some sort of like doctor or more specialized software, you do need to figure out how will users be using this, and then building like a proper like test set or benchmark that actually reflects this use case.
Okay, so human feedback, that's good. So are there any more automated methods that people use, or not really?
It really will depend on like the use case. So for example, for translation, we have like kind of people have studied these metrics for just like the proper evaluation, and even how to do the human evaluation could be tricky. So like maybe automating like automating certain parts of the human evaluation is of course important. I mean, of course, I think at some point we will have to do more model-driven evaluation. So like having models to evaluate other models, and this will become like this is not just convenient, but it will be a necessity at some point, especially as the models become superhuman at whatever task that they're doing.
Right. I mean, when I study like NLP and stuff, there's always like, they always mention the BLEU score and the perplexity. And of course you can use the actual loss function for ways to measure, but these kind of, what do you think of these methods?
Yeah, so I mean, so they all have their flaws, right? So like obviously like perplexity, like it's not really clear how useful that is. Like as a way of really measuring like if the model is really capturing like the knowledge that you want. Blue scores are of course
Before you move on, so what's up with perplexity? What are the flaws with it?
I mean, it's just a number, right? Like it's not necessarily tied to the task that you want. It could change depending on what test set you use for that. And then it doesn't really capture decoding, right? So you don't know kind of what kind of answer the model will actually give. And it also requires you to have some notion of the correct answer, right? And for some cases you may not even have an answer, or maybe there could be multiple different answers. Maybe the model really likes one of them, but that just doesn't happen to be the one that you have. So like, for example, if you had like lead code problems, right? There are multiple ways of solving a lead code problem, and so perplexity might not capture all the modes. And I think in general, like I think people like, it's not that we don't like perplexity. I just think that we need to be more like closer you are to the downstream task, the better.
Gotcha. So maybe it's not aligned properly. I hear this
Right. Exactly.
a lot.
Yeah. Right. Yeah. Correct. I mean, like I think like we can be. I think it's a bit vague as to what aligning means, but yes, something along those directions. So that's for perplexity. For things like blue scores, it's kind of also similar issues. So blue scores requires you to have a target, and then makes like a comparison. Blue in general has been quite bad. I think people just don't trust it. Right? Like it doesn't make sense for code. Even for translation, people are slowly moving away from it, using more like learned metrics. And so I think the field of like doing proper automatic evaluation is advancing beyond just like the simple heuristics that we had before.
Oh, I think that's probably a good thing. Sounds good.
Yeah. I mean, it's long overdue, I think, but.
Cool. So yeah, I guess that's a big open question. So how will we decide which models are good, and how much? Yeah, I guess it's hard to determine how much better a model is versus another, which we kind of talked about earlier with the the llama versus the GPT-3 and other chat GPT and stuff.
Yeah, and I want to highlight that this is actually like very subtle. So, for example, in the Instruct GPT paper, they compared like their approach versus just fine tuning on like a bunch of different tasks and trying. Like I said, I think like Flan, for example, explores the approach of like doing multitask fine tuning to enable better capabilities, and they found that so if you do that, then the performance on benchmarks on academic benchmarks goes up. But if you look at the actual human evaluations, it goes down. So like this sort of suggests that like maybe these academic benchmarks are not actually capturing what you are not actually capturing the properties that you want to be captured by your evaluation. So this further raises that concern, right? Because people build models using these as the benchmarks. So you can imagine that maybe we're going the wrong way, or we could be going the wrong way.
That makes sense. Yeah, so I guess that makes sense. And also, I guess, a lot of people are probably trying to use these language models to do certain downstream tasks. And that might be, I don't know, comforting to hear that maybe human evaluation is actually one of the better methods that we have to do this kind of thing, to figure out what's actually working or not. Yeah.
Yeah, it's just like slow and also has its own problems. But yeah, I think at the end of the day, that does seem to be like the best path forward for now.
So speaking of, and also, okay, so kind of zooming out again. So we mentioned two things and that kind of came out in the news, and the other was GPT-4. So yeah, let's talk a bit about that, I guess. What's your take on it?
Yeah, obviously, like I think the performance is great. I didn't feel it was as like say transformative as the leap from GPT-2 to GPT-3. But of course, like I think there are so many kind of interesting nuggets there. I like, for example, the fact that it's like multimodal, or that it has additional like capability to ingest images. I think people have like there was a recent paper from Microsoft where they actually did some experiments with GPT-4, and they just tried it out for a wide variety of tasks. And I think it is kind of cool seeing just the kind of things these models can do. And sometimes I worry that maybe the reason why I don't think it's as a big of a leap is because we don't have the way to evaluate that. And maybe if we had more crazy benchmarks, then we could really see it actually like do more impressive things. But just in general, I do like their evaluation protocol. Like, so OpenAI released this paper where they also showed multiple evals. I think it was cool. Like they had like a lot of like the performance on many of these like standardized testing suites. So it is kind of interesting to see just how the models fare in these tasks, and like just how the performance keeps going up.
Cool. Yeah. What do you think of the context window? For GPT-4, it was an improvement, right?
Yeah. So I think there's one of the versions has 32K context length, so it's quite long. I think they say that they can fit like 50 pages of text in context. And even during the demo, they were able to fit like big parts of the documentation just in context. So I think it's great. I think we're also getting to a point with like one context where like it's not super clear if it's not super clear if we want to go bigger in context, or whether we want to invest in other types of technology that allows us to just like use like context. Like for example, like do you really want to fit a whole book in context, and like as opposed to like maybe having alternative mechanisms like some sort of like retrieval base, right? So
to give the model some sort of memory.
Yeah, sure. Yeah, right. I think memory is one way to like get around this.
Or retrieval from the internet, maybe.
Right, exactly. So I think the internet is like the best example where like you can't fit the whole internet in context, right? And like it would be dumb to do so.
Not yet.
Maybe, right? But obviously you still want to be able to like have access to it, right? And so like obviously now people are equipping these models with like search capabilities. And so I think like, to what extent do we need long context versus just more capabilities like search or things of that form? I don't know. I mean, I do think 32K content does give you the ability to do lots of fun things without having to worry about this like search or whatever. So maybe we should just keep going up. I don't know.
Yeah, I mean, it's pretty cool. In the demo, they show like, because the model gets trained at some point, and then, maybe your coder and some new version of your whatever framework you're using comes out, and then maybe you can just input the whole new documentation along with what you're trying to do, and hopefully the model can figure it out. That's pretty cool.
Yeah, no, for sure. I mean, I think it's very exciting. I'm just not sure if like that is really the correct way forward. So like, if like, like imagine some sort of lifelong learning agent, right? Where you keep going on. Then at some point, like no matter how big your context window is, you're going to like run out, right? And so like at some point you have to somehow figure out that you want to save the information that you have, or like I think like it just doesn't seem like something that's like sustainable. So I'm hoping at some point we'll figure out some path forward.
Right. You kind of allude to what if you want to create, AGI or something like this? How is this really the way forward with a finite, like with a, big, but, finite context window, or maybe you need some other mechanism in place. Yeah. I think I get your point.
Yeah, I think about like humans, like obviously like we have like long-term memory and short-term memory, right? And like we have all these things, and like it's not clear. I mean, so one, it's not clear whether we should whether we should make our models kind of be similar to us. But I think the models also have this issue, right, where they store knowledge in their weights, and then now we have knowledge in context, and at some point we need to figure out how to move that in context knowledge to like the weights again. But
Future work.
yeah, hopefully, yeah.
Maybe done by you. We'll see.
if only.
I think we can call it here. So yeah, thanks for
Cool.
joining us, and yeah, appreciate you taking the time to talk with me.
All right. Anytime.
Great.